What's up, guys? Today we're going to be talking about core collapsing supernovas. So to start, we'll talk about what is a core collapsing supernova. So when a star that is generally about 8 to 40 times the mass of our sun runs out of fuel in its core to burn, it will begin to collapse in on itself due to gravity. Now once the star fully collapses in on itself, it will create a massive explosion, which we call a supernova. Now, generally in our galaxy, supernovas occur about 1 to 40 years or so, but in the universe, supernovas are happening all the time. Now, an interesting thing about core collapsing supernovas is that they emit most of their energy in the form of neutrinos rather than photons. And these neutrinos are able to escape the star hours before the photons are even able to, due to the denseness of the gas around the star. Now, neutrinos are almost massless particles that are the most abundant particle in the universe. In fact, thousands of neutrinos are flowing through us at this very moment. Now, because they very rarely interact with matter, they are incredibly hard to detect. Yet, we can still perform a calculation in where we can determine how long we have from when we detect the neutrinos to when we'll detect the photons, according to the star's mass. There's only been one core collapsing supernova that we've been able to detect neutrinos from so far, and that is supernova 1987A. Here's a photograph of that current supernova. It's a very pretty one. Another nebula that was formed in the result of a core collapsing supernova is known as the Crab Nebula as well. Now, the results of these core collapsing supernovas can depend largely on the mass of the star originally. They can either result in leaving behind a neutron star or a black hole. Now, a neutron star is just the core of the star left behind, that is packed super densely of neutrons, and neutron stars are some of the most dense stars in our universe. Now, the other result is a black hole, in which is just basically an infinite well that sucks up pretty much everything around it. Another cool thing that results from these supernovas is the explosion produces most of the heavy metals that we know, such as iron, silicon, and gold, and they also create most of the atoms that are in our bodies and DNA. So essentially, you can say that we are made of stardust.